video, we're going to be using logarithms to calculate pH and pOH. The acidity of a solution is based on the hydrogen ion concentration. Because those concentration values we've seen were messy, 1.2 times 10 to the negative 8th. Who wants to write that down? So a scientist many years ago developed a pH scale. And this pH scale was a logarithmic scale developed so that we could easily represent the acidity of solutions with much simpler numbers. So how do we calculate pH from hydrogen ion concentration? The pH equals the negative of the log of the hydrogen ion concentration. And to go along with that, the pOH is the negative of the log of the hydroxyl ion concentration. So let's do an example. What is the pH of a solution with a hydrogen ion concentration of 1.4 times 10 to the negative 8 moles of hydrogen ion per liter? We're going to be using this formula because we're looking for pH. So my pH is going to equal the negative log of my hydrogen ion concentration. So that's 1.4 times 10 to the negative 8th. So I'd like to keep that negative out front because a lot of times I'll forget, change the sign on my logarithm. So I'm going to go ahead and put this into my calculator, and I get negative, so I've got my negative out front and then another negative, 7.8539. So my pH comes out to be positive 7 and let's go ahead and round it to the nearest tenth. So 7.9 is my pH for this given solution. Now what does that mean? Well, what we like to talk about is a pH scale. Here is what we have for the hydrogen ion concentration. Here is the pH, much simpler. So let's look at some examples. Stomach acid has a pH between 1 and 2. Lemon juice, 2 and 3. Vinegar's right around 3. Milk, pretty close to neutral, between 6 and 7. Pure water, right in the middle. 7 is neutral. Blood, it lands between 7 and 8. So what you see is the closer you are to 0, you have an acidic solution. Then you have your neutral. And the closer you are to 14, you have a basic solution. So now, how can we use this in our calculations? This comes directly from multiplying the ion concentrations for the hydrogen and the hydroxyl, and we get that 1 times 10 to the negative 14th. Well, pH is much easier. pH plus pOH, that has to equal 14. So in that previous example, we had a pH of, 7.9. So what would our pOH be? Well, we would substitute in 7.9, so we'd have 7.9 plus pOH equals 14. Solve for this guy. And I'm going to subtract 7.9 from both sides. I get my pOH equals, let's see, 0.1, 6.1. So that would be my pOH. So in this example, a solution of 1.2N, so that means a normality of 1.2, and it's an acid, is known to be 10% ionized. Find the hydrogen ion concentration, the hydroxyl ion concentration, and the pH and the pOH. Let's start with the hydrogen ion concentration. We remember that normality times percent ionization will give me my hydrogen ion concentration. So my normality is 1.2. percent ionization is 10%. So I need to convert this to a decimal. So I have 1.2 times 0.10. That'll give me my hydrogen ion concentration. So I multiply these two and I get 0.12. I can leave it like that, or I can convert it to that scientific notation, which would be 1.2 times 10 to the negative 1. So that would be part A. Part B says, now I have to find my hydroxyl ion concentration. Well, how did we do that before? We knew that the product of the hydrogen ion concentration and the hydroxyl ion concentration equals 1 times 10 to the negative 14th. So that's the formula we're going to use. So let's substitute in our hydrogen ion concentration from part A. So 1.2 times 10 to the negative 1, and I'm going to multiply that by my hydroxyl ion concentration. Now I need to solve for that hydroxyl ion concentration, so I'm going to divide by 1.2 times 10 to the negative 1, both sides, and I get 8.3 times 10 to the negative 14th. So part C says find the pH. Well, we know the formula for pH equals negative the log of the hydrogen ion concentration. My hydrogen ion concentration was 1.2 times 10 to the negative 1. So I put that into my calculator and I get a log of negative 0.9208. Now don't forget that leading negative. That's a common error. So I end up with a pH of positive 0.9208. That's part C. Now for part D, we have to calculate the pOH. So we can do this one of two ways. Let's do pOH equals negative log of the hydroxyl ion concentration. Okay, here's my hydroxyl ion concentration. So I have minus log of 8.3 times 10 to the negative 14th. I put that into my calculator and I come up with a log of negative 13.0809. Let's change the sign. Comes out to be positive 13.0809. Whoops. Sorry about that. The other way we know how to look at these is the sum of those two must equal 14. Well, let's use that as a check. pH plus pOH has to equal 14. So here's my pH. Add to that my pOH. Is that going to equal 14? Well, I add them together and I get 14.0017. That's pretty close. Close enough.